Hey everyone, you're listening to the Simple Electronics podcast. I'm your host, Simple Electronics, and with me today I have a very special guest, John Park. How are you, John?
Hey, hello, Dan. I'm doing well. Thanks for having me on. I'm really excited to be a part of this.
The pleasure is mine, actually, because you actually came as a reference, I believe, from Scott the Deaf Palm. That's true, right?
It was maybe Scott from Adafruit. It may have been Johnny Bergdahl, also, who was a guest, I think, on your podcast, and he sent me a message on our Discord and said, "Hey, would you like to be on a podcast?"
Okay, it was Johnny, because Scott's been sending me a lot of people.
Right on.
Scott, the Deaf Palm, not Shawcroft. Yeah, it was a little confusing to know where all the emails were coming from, because for the first
Johnny.
time, yeah, it was Johnny Bergdahl for sure. Because now
Right
for the
on.
first
Thanks,
time,
Johnny.
I'm getting inundated with people who want to come on because Johnny has a lot of reach.
Terrific. That's terrific.
Yeah, so I looked you up a little bit before this interview, and you're the first guest I've ever had with a Wikipedia page. I don't know if you're aware of that.
Yes, I haven't been there in a while, so I'm not sure how up to date it is, but I know that someone put that up a few years ago when I had done a TV show. I think that was enough for someone to put something up there.
I mean, a TV show is quite the credential, but we'll see how accurate it is. So can you let the audience know a little bit about yourself, what you do, and what you like?
Sure, yeah. So I work as a content creator for Adafruit Industries, primarily. I'm a contractor, not an employee, but I work from my home workshop in Southern California, and I build projects using electronics and microcontrollers and digital fabrication and tools, hand tools, things like that. And then I create tutorials on the Adafruit Learn system that shows people how to build similar things or the same stuff or use it as a launching off point. And I create video to accompany that, as well as doing 2 live streams a week for Adafruit that are on their YouTube channel and other places where Adafruit broadcasts. And that is my main thing I do, is create stuff and share with people and show people how to build stuff using these tools, using the software and libraries and things that go along with it. So that's what I'm doing now. I've been with Adafruit pretty much full-time for 5 years now. And prior to that, I had about a 20-year career in computer animation, computer graphics and animation, working mostly in animation, in the animation industry, places like Disney and Sony Imageworks, and prior to that in video games, and kind of generalized what used to be called multimedia, a term that probably isn't used as much anymore. So that's what I did, and that's what I'm doing now.
So your Wikipedia page is actually fairly accurate then, because you pretty much touched all the points there. So that's pretty good.
Good.
Well, a lot of people today are in the gig economy, and I'm in the gig economy myself. I'm a contract professor for I'm an automotive trades professor at a college. Mm-hmm. What's it like being a contractor for Adafruit?
It's been a big change in many ways, because I was working pretty much my whole career at companies like Sony and Disney and IBM. So I had worked at some smaller shops, I'd worked at some smaller game studios, but I'd always been someone working at a company where you got benefits and you had vacation and all of these sort of typical luxuries of working for a company that has HR departments and 401k plans and those sorts of things. So I was, somewhat unconventional in that I was working from sort of movie to movie within studios, and sometimes going to a different studio when new shows were starting up. But I was working for Disney for 12 years, so I was used to that kind of the perks of that kind of job. So going to essentially working for myself and having Adafruit as my biggest client early on, I also had some other clients that I was doing some side work for and fabricating things for, repairing some equipment for Disney even. But now I've just got so much, the Adafruit has so much exciting stuff going on and so much room for me to work that I just am doing that full time. It was really an adjustment to be working from home and not leaving in the morning and going somewhere and then coming back. It was a big adjustment for my family as well. Thankfully, I have a sort of home office and studio that I use inside the house, and then I have my workshop outside the house. It's essentially what was a detached garage. So I'm out of people's hair for the most part, but I really enjoy what I do because I have a lot of freedom and autonomy to create things with lots of great support and direction from Phil and Limor and the rest of the Adafruit gang, as well as the sort of wider Adafruit community. So it's been terrific. I'm loving it. That's why I'm still doing it 5 years later.
Do you get to interact with some of the cool people inside of Adafruit? Like, I mean, we hear Lady Ada all the time. Do you work with Scott Shawcroft?
Yeah. So we have the answer is yes, and the way we do that is there's a Slack group called the Creative Engineering Team, and so we're essentially on that all day long with questions and answers and conversation. And then we do a regular sort of meeting that's a video call every week to just update everyone on what we're doing, as well as if anyone is going to ask someone for help getting something unstuck, or just give someone a heads up or solicit ideas. That's a really nice weekly touch base that we have. And then there's a wider Adafruit State of the Fruit meeting, which is like an all-hands meeting that happens on Fridays, and that's also it's actually what was just an in-person meeting prior to the pandemic in the offices in New York where Adafruit is, and I had been to the offices a few times and been there when it happened and thought it was really cool, but then we weren't participating when we went back home to wherever the remote people went to. And there's about, I don't know, maybe a dozen of us who work remotely like I do. During the pandemic, since everyone was at home, they made that meeting a video chat call, and so they've continued that on. So it's been nice to have another place to sort of hear what people are up to, what some of the other departments are up to, and stay informed.
So there are some people who feel a bit of despair about the gig economy, but can you tell us like a few of the things that working for Adafruit as a contractor has allowed you to do that you really weren't going to be able to do before working for them?
Mm-hmm. Yeah, so I had done a lot of work with Make magazine early on, and that's sort of how I took about a decade to transition from working in animation to working full-time at Adafruit doing the things I do now. So I had worked for Make magazine writing articles on how to build stuff, and would present things at maker fairs and do talks, and that's actually eventually what led to me hosting the TV show on public television for Make magazine. The difference was, though, I was working a full-time job, and then on the side I was doing these builds of Arduino-based projects and things like that. The transition to this sort of gig economy version of it is that it's my full-time thing, and it's sometimes they say don't turn your hobby into a job because you'll kind of ruin the thing you're doing, but sometimes that's not true, and I've really loved being able to focus 100% of my work hours, energy towards these projects, because they, thankfully for me, the types of projects I build are still the types of projects that I was building when I was doing it more just for fun or for these sort of freelance articles. So I think that the weird freedom that I have, and I say that in a good way, but the fact that I get to have sort of creative brainstorming sessions with Limor and Phil about, hey, we're going to be doing this AdaBox unboxing. And if people aren't familiar, Adafruit does this quarterly subscription box that is a box full of some kind of new Adafruit product and the sort of accessories that go along with it that you get in the mail. And I get to do this unboxing video where I show what's in the box and how you put it together and a couple of the demo projects. And I get to pre-record a video for that and do a follow-up on the unboxing night where I'm doing a live stream. So those have become so much fun, and the fact that we just sort of brainstorm, hey, this actually really got cooking last October when Phil and Lamore said, hey, we're going to do this box and we're theming it after the Rocky Horror Picture Show. It's called Rocky Horror Pixel Show, and it was based on an LED matrix display and a board that was designed to drive it pretty easily using CircuitPython or Arduino. And they said, just run with this. And the fact that I get to play with that and dress up as characters and find creative, fun ways to present this stuff, as well as build the projects that I'm going to show that are going with it, and other people build projects and write tutorials as well. It's not a solo effort. That's incredible. When I worked at Disney Animation, that was a building with about 800 people in it, all working towards making a movie. And it's an incredible thing, but it's a very different thing than having sort of a launch and a few touch bases, but otherwise being responsible and yourself to get the job done, which is just a lot of fun to be able to really run with things like that. I've enjoyed the heck out of that.
See, I feel like that's the dream as aspiring YouTuber. There we go. Words are hard today. I feel like those are the kinds of things I'm like aiming for in the future, being able to sort of do creative collaboration and sort of follow my whims, and then eventually make some pocket change out of it. Like, it's never going to be, I don't think it's ever going to be a full-time income for me. I don't see it happening in such a niche like electronics. It is possible, but there's some people that are far more talented than me that can't make it work. So it is what it is. But the collaboration, the going to maker fairs, the building projects that inspire people, that kind of stuff is what I'm aiming for. So you're
That's
basically
great.
living my dream there.
Thank you. Well, it's interesting. I think that you say that, but it's such a wide open field still, I feel, compared to 15 years ago, when if you were going to do something like this, you were going to have to pitch a show. You were going to pitch a show to a television station. There wasn't a way to really do this sort of stuff on your own unless you made a pirate radio station or something. So the fact that we have platforms, particularly YouTube, that aren't there aren't gatekeepers in the same way as there were somewhat by necessity, because it was such a scarce resource of hours to broadcast. So I feel like it's a much more open field, and coming up with your angle on how you want to do things or your particular audience is still not really. I think it's still in its early-ish days. And to be clear, it's not like it was in the early days of YouTube, where you could make enough money on ad revenue to just grow a big enough audience and you were set. So I think it requires creativity beyond just what platform are you on, but how are you appealing to people to make money on Patreon, which seems like a really popular way these days. And I think that more things like that will happen. There's money to be made, and people will want to figure out ways beyond just YouTube and some of the earlier methods for that. So I feel like it's out there, and there isn't a prescription for this is how you have to be to fit inside of a system.
Yeah, that's very true. It's more open than it ever has, right? Like, because you'll see creators from Podunk Town, Podunk Country make it big on TikTok, for example, these days. So
right.
The possibility is there. I'm just trying to be a little realistic with my expectations. I think I will be proud if I build something that's nice enough, that's good enough to be at a maker fair, and that draws a crowd. That kind of thing. Like, get that kind of impact is something I would be really into.
That's terrific, and it's so much fun. I miss those. I really do miss the in-person maker fairs. They're hopefully coming back. I think the last one I went to was Miami 2 years ago, and then last year I did the Miami Maker Faire online, which they did a really nice job with. But it's just apples and oranges compared to being with people and seeing what people have brought and getting to talk to people about what you've made.
Especially in the maker community, because I feel like there could not be a more diverse set of people, but the mentality is so convergent. Like, I've never met an evil maker. You know what I mean?
Not that we know of.
Yeah, not that we know of. That's true. Well,
no, it's true. It's such a sincere group of people and a sincere endeavor to get together and essentially do show and tell of something you're proud of and excited about. It's wonderful. I really enjoy the energy of that, and that's actually been something I think the Maker Fairs and Make Magazine really helped to set the tone for this this maker movement as one that was open and accepting and sincere and enthusiastic and not cynical. And in fact, that was one thing that really appealed to me about the Make TV show as they were getting it going, and they were starting to audition people to host it. But I actually got to co-write the episodes, the projects that I worked on with a tremendous guy named Bill Gerstel. I think some of the early concepts of the Make TV show before it came out, got some producers involved who wanted it to be sort of they wanted to compete with Mythbusters, so they wanted to blow things up and get slow-mo cameras. And that eventually those relationships dissolved and they went in the direction they went, which was with the Twin Cities Public Television, who had a 20-something year history of making Nova and really good, sincere, enthusiastic, non-cynical science programming. So it was a really good match to be able to carry that tone through from the Maker Fairs and the magazine into the TV show.
Yeah, just looking at your work history, you're at least in 2 of the top 5 companies that were like early to push the maker movement forward, because Make and Adafruit were huge. Like they were right there at the beginning, I think.
Yeah, for sure. And it's all one big family in a lot of ways, because from those early Make Magazine and Maker Faire days, I knew Phil Terone because he was the founding editor of the Make Online side of things, and Phil also was the guy who'd started Hackaday, so he had his fingers in a lot of related things. So it's he's a hub, and there's a sort of network of people that sprout out of some of those early relationships. We were all hanging out together, Massimo from Arduino and Nate from SparkFun. It was a small group that just went out and did great things and got bigger and bigger.
And obviously you were saying that the producers of Make the TV show, they wanted to compete with Mythbusters, and I see that you've worked on Matrix Reloaded and Matrix Revolutions. Is that right?
Oh yeah, when I was at Imageworks, I had a really cool job there. Sony Pictures Imageworks is a visual effects company, and they're mostly up in Vancouver now. A lot of the VFX industry moved from Southern California to Vancouver in the last 10 years for money reasons. But at that time we had the facility here in Los Angeles, and I was a digital trainer there, so I got to essentially learn and teach all of the different software in the pipeline for visual effects. So that's everything from lighting and rendering to compositing to modeling and animation. A lot of it was off-the-shelf software, a lot of it was in-house homegrown proprietary software, so I got to really get familiar with that whole pipeline, and I got a chance to work on a few shots in some of the Matrix movies, and little bits and pieces here and there on Polar Express and some other stuff. So it was fun, because a VFX shop has 8, 10, 12 shows going on at the same time. They had a few Harry Potter films happening, and Spider-Man 2 was happening, and they were just starting to do some of those Bob Zemeckis mocap films, and they were also just getting the idea of Sony Pictures Animation off the ground, so I helped with some of the development tests for Surf's Up, which was one of their first fully animated pictures out of SPA.
I just find it hilarious because Make the TV show was kind of like Mythbusters adjacent, and then you worked on a couple movies that a couple of the Mythbusters cast, like the original cast of 5, I guess they were. I think 2 or 3 of them worked on the Matrix movies. So.
Oh yeah, in practical effects stuff, probably,
yeah,
right?
Exactly. So you're doing VFX, cool. And they were doing practical models. So it's like, what a small world. It's
funny. When I was coming out of college and into the workforce, I pretty quickly started working in digital graphics types of things. But I really was interested in getting into practical film special effects, and that was sort of when that was dying. So it was like a really bad timing. If I had been 10 years earlier, I might have been able to go into it. But computer graphics, which is, ironically what I ended up working in, really shifted a lot of the work away from practical effects. But I was so fascinated with practical effect gags and, armatures and prosthetics and stop motion. All that stuff is really cool and tangible.
Yeah, no kidding. And I feel as though recently, with the sort of the explosion of popularity of 3D printers, the sort of shift from the digital back to the physical is sort of happening again, because people now, I mean, anybody can pick up FreeCAD and make models, but now you can print them out and have like a physical object you can touch. And a lot of people learn a lot better, physically rather than digitally. So it's kind of everything is making full circle, or something.
I agree. Yeah, I think the thing that really excited me, the timing of when Make magazine was coming out, was great for me, because I had been doing everything in the box and pushing pixels around and rigging characters and things like that for about 15 years or so, and I hadn't really been building stuff with my hands. And I used to. I built props in the theater when I was in college. And had always tinkered with stuff and taken things apart and built things, but I had spent a decade and a half so focused on computer graphics that I wasn't doing anything with the real world. So when Make came out, it like awakened this thing in me where I was like, wait, I need to start building physical, tangible, visceral stuff again. And the fact that some of that was just straight up me learning more about electronics and building small, silly little circuits, but a big part of it was the fact that a lot of skills I'd honed doing computer graphics were suddenly transferable into 3D printing and tool paths for CAD or laser cutting. I got really excited about those things because they were a way to use the digital skills that I had acquired in building physical stuff.
Yeah, isn't it great how making is sort of like all-encompassing? There really isn't any categories that we can think of that can't be considered making. Like, making is everything, which is awesome. Can you talk to us about that transition you did about learning electronics? Like, what route did you go to learn to make electronic circuits and use electronic devices? Because I can tell it's not your education, not a formal education at least.
Right, yeah. So I had been interested in electronics when I was a kid, just a bit, just enough to ask my parents for a Radio Shack 150-in-1 kit so I could build all of the different little radios and buzzers and photo sensor-based theremins and things like that. And if people aren't familiar with those it was a boxed kit that had a sort of spring-loaded breadboard system with on a cardboard surface that showed you where to connect things. So it had sort of some internal patching and some patching you would do just by putting the leads of a resistor underneath a couple of spring clips. And it came with this recipe book of 150 experiments that you would do to learn about different types of electronics. And so I did that, and I had fun with that, but I never, and to this day, I don't have a great understanding of electronics and circuits. I can get things done and mostly copy paste from things I've done in the past or schematics that I see that other people have done. But I think what I was craving at that time didn't really exist, which was this more hybrid of microcontrollers and electronics, and that's what really opened up for me, the ability to build things that I envisioned. And so I think something about having a little bit of software and scripting kinds of things mixed with a little bit of electronics and a lot of help from the designers so that things pretty much just work when you plug them together. You might have to build your own little level shifter or something simple to make the thing work the way you want, but it's not crafting electronics from scratch, which is not, like you said, it's not my formal education, and it's not something that I think I'll ever really wrap my head around well enough to be designing circuits from scratch. So I'd done some of that, and I was really into my Apple IIe when I was a kid, as a playing games on it and doing stuff like Logo. I was interested in graphics a little bit and trying to hack games a little bit with with instructions you'd find in BBSs and things like that. And then a long period of time went by where I just wasn't that interested in electronics or computers. There wasn't a lot that was exciting me about it. And then just as I was in the last couple years at college, I had a roommate who was a recording engineer, and I was singing in an a cappella group, and he was recording and mixing an album, and I got really interested in that, and so I kind of got a bit into the computer side and just the straight audio engineering side of things, and ended up learning about and doing audio for theater as well. I was a theater major, so I had a lot of kind of neat maker types of things around me, even though that term wasn't being used and I didn't really know it at the time. But I ended up, learning a lot about prop building, learning a lot about lighting, learning about sound design and sound engineering, all these sort of crafts and skills and set building that you get in theater. Plus my major was in acting, so I was doing stuff on stage as well as off stage. All of those things are really weirdly similar to what I do today, which is video production and live streaming of myself making things and presenting. So weird surprise that the thing I was studying in college ended up being relevant. But back to your question, I think getting excited and interested in those things at that time, I was still somewhat stymied by the complexity of the tools and the audience that stuff was for. I at one point thought I wanted to get interested in like PIC microcontroller programming or other things like that, and it just seemed so impenetrable, the level of knowledge you had to have going into it and the tool chains you had to build for it. So it really took Arduino and the sort of artist-friendly, maker-friendly approach that they took to really unlock things for me. And so that's when I started to dive deeper into building things based on demos and tutorials, and then bugging friends of mine to show me how to do things that I couldn't figure out how to do. And I think the motivating thing for me, you might be able to tell, is wanting to build stuff, like having my eyes on, I really want to make this 3D printed prop laser cannon that has this sound effect and these lights. So what do I need to learn to be able to do that? And then I would kind of break it down into the different demos and small bits of modular pieces of the project, and learn enough to be dangerous, and then try to coalesce it into the sort of finished thing that I want to build.
So kind of like a project-based approach was kind of like your way of learning more. You use that as a vector, kind of.
Yeah, very much so. I think the things that help me learn the best are approaching things with some kind of a project I want to build, and then figuring out what knowledge do you need to get there. And sometimes that's not realistic. You may pick something that's so big that as you start to learn about it, you go, okay, this is absolutely not the time for this. So revise your expectations. And then teaching. And so I really find, particularly with computer graphics, I spent a lot of years teaching people animation software. And it was always such a great way to learn more about the topic or the particular tool, because people will come at you with different points of view and different expectations or projects they want to do, and they'll ask you questions that you just need to learn how to figure out, rather than, you're not going to come in knowing everything. So I really love teaching things as a way to learn them, and so that's to some degree, what I've been doing with Adafruit is finding small projects that I want to write up and do a tutorial on or show off. Okay, well now I got to learn how to do it well enough, and I'm not claiming to be an expert, and my code isn't optimized, and there's better ways to do things, and you'll see people who will look at a project and say, you could do all that with a 555 timer and it would cost you 10 cents. Why are you using a $30 microcontroller? I get that, but it's also the fastest way to the result I want, and so I'm okay with that. I'm at one with that.
Yeah, I face that kind of scrutiny all the time because I have, like, for example, I have a project in mind where I just need to pulse. All I need is a pulse, but I want 2 pulses of 2 different speeds, and so I can make 2 separate 555 timer circuits, or I can use like an ATtiny 85, which is like $1, and it can easily it can pulse 4 different speeds if I want to. Like it's super easy, and then my component count drops like significantly, right? Because the 555 needs support components. So yeah, I've been wrestling with whether or not I should just do it the way the comment section is going to want me to do it, or just do it to get it done.
Right.
Because
I try to generally avoid. It's impossible to ignore, but I generally try to avoid doing things because of the fear of the vocal naysayer that's going to show up in a comment. I can profess innocence. I was never trained in any of this stuff. I'm doing the best I can and having fun with it. And so I'm not. Of course, people are right in a lot of these cases, especially if their goals are different. If their goals are to make a product that has a low part count or is done efficiently or doesn't have software debugging, absolutely, there's valid reasons. Other cases, it's gatekeeping, or it's coming from a negative place, and I try to basically ignore the temptation to cater to that crowd.
Oh yeah, because they miss the big picture. I think every one of those comments that come from sort of like either a gatekeeping or demeaning stance, they miss the big picture that, if you're going to make a circuit with 555, you're going to have like 18 solder points, right? And if you make it with let's say like a Digispark, you just solder a single wire to come off your output and you're done, right? There's a bigger picture. Sure, if you're making 1 million of them, the 555 timer circuit is probably more economical, and the pick and place machine doesn't care if you place 1 part or 10 parts. But we're hobbyists here. We don't do things for production. But I think a lot of people are kind of like, stuck in their narrow views that this is the way their professor told them how to do it in 1995 when they were in college, and that's the way you're supposed to do it. But,
Yeah. Well, there are a lot of different goals, and there's a lot of different constraints, and I think there's room for all of them. So, so I think that's one thing, again, that I really appreciate about the community around Make, the community around Adafruit, is that it tends to be pretty accepting. In fact, Adafruit in particular does a lot of work, has done a lot of work, really hard work, to try to make a safe, accepting environment, which doesn't mean that people don't ask for, or sometimes aren't asking for, but get good critique. But it's a I think in the end we get further with open, accepting in this type of a hobbyist community than we do being sort of prescribed about this is the way to do things. I know that if I, to use your example, well, yeah, you may go with just 555 timers, but the fact that you probably are more likely to do bigger and bigger projects that require microcontrollers than using your ATtiny now is setting you on a path that might be a little more in the direction that you want to go. So microcontroller overkill is all good in my book.
Oh yeah, absolutely. And I can give you even a practical example. The Adafruit Circuit Playground Express. It's a bunch of NeoPixels. It's got temperature sensor. I believe it has a barometer, tilt, like a gyro, and it's got So yeah, it's a microcontroller with a couple of support things. Can you get that cheaper if you buy the components separate? Absolutely. But then if you're a beginner, do you really want to be checking and triple checking all your connections every time you just want to try if something works?
Yeah, for sure.
That's what people need to they need to big picture it, right? If you're a beginner, just connecting things on the breadboard is daunting. The breadboard is not like wire to wire, right? It's like some of the rows are, the rows of 6 are connected together. But on the other side of the breadboard, it's not connected to that side, and the power and ground rails are not connected to the rest of the breadboard. So,
it's funny. I love the Circuit Playground Express, and particularly, I think it's great for people who are coming from the software world and want to start getting into hardware because for the reasons you said, the hardware is going to just work. Everything is sort of figured out in advance and you're not wiring anything, so you can immediately start to say, okay, if I want to make half the LEDs light up one color when I hit one button and the other half go a different color with the other button, that's only a software problem. So long as you're providing the thing, proper power over USB, it's just going to work. So it's purely a software to hardware exercise where you're not troubleshooting that, which I really appreciate because when I have taught how to build projects using microcontrollers, the number of things that can go wrong with like breadboard wiring or even setting up an IDE if it's Arduino. I'm actually dying to teach an in-person thing using Circuit Python because of that very reason. As long as you have a text editor, there isn't anything else required. I taught a class at SuperCon a few years ago of building a sort of conductive paint-based DJ controller on a pizza box, and it was on a Circuit Playground Classic using Arduino, and we ate up about, 25 minutes of a 2-hour session with Arduino IDE issues that people were having, and that's no slight on Arduino. It's just anytime you're trying to get software installed on people's laptops, you're going to run into issues. So I'm actually, I would love to revise that class and do it in CircuitPython just because I know, okay, as long as you've got the thing plugged in over a proper USB cable, we're done. Like everything else is just typing in a text editor. And on the flip side of that, I think the fact that you can use alligator clips to hook this board, the Circuit Playground Express, I'm holding one in my hand, which is why I'm saying this board. If you want, you can clip it to other stuff, add LEDs, add other circuits and inputs and potentiometers, so you start to expand out into using peripherals, but again, it's sort of point-to-point connections. There isn't the mystery of the breadboard under there. And then eventually, depending on someone's goals, you might introduce them into the breadboard as a way to introduce them into things like prototyping and putting them, soldering things to a perma-proto board, and eventually actual circuit board design. So I think there's a really nice continuum that you can go there, starting with these types of development boards that have a lot of stuff built onto them.
Oh, 100%. And like part of this new program at the college that another professor and I have built, we have to teach new students computer competency, because in the automotive trade, all your information systems and stuff are on computers. And we've watched repeatedly students try to log into the information system on the Windows login. Like, people need to understand that not everybody has the same amount of competencies in every single aspect. So
yeah, that's interesting. Yeah, I think we have a lot of people coming at their educations from mostly mobile operating system points of view. They're not necessarily coming from desktop computers and laptops, is my guess.
That's right. And Scott Shawcroft, and when I interviewed him, he was talking about Adafruit, or I don't know if it was him or Adafruit in general, there was a push to making things maybe programmable through a phone, because most people know how to use a phone.
Scott and Adafruit are working on. Yeah, for sure. And it's a question that I've been asked by educators in particular a lot over the last couple of years. How do I use an iPad or an Android tablet and that's it to program a microcontroller? And the there's a really cool environment for programming microcontrollers that Microsoft Research created. It's called Make Code, and it's often associated with the microbit microcontroller from BBC, but it works on the Circuit Playground Express boards and then a whole bunch of other boards now, and they have a version that's for making sort of 8-bit video games that run on little boards like the Pi Gamer that have a display and some buttons and a microcontroller on there. But the sort of holy grail for a lot of educators I've talked to is that, which is a drag and drop graphical UI, like Lego block kind of UI for programming, for creating the logic, and then you hit a button to upload. Those are only running on general purpose computers. They're not running on or rather, I think you might be able to run them, but you can't upload to your microcontroller on the device itself, which is a big bummer, because if you could get a bunch of tablets into a classroom and have people dragging and dropping little connections around to create their logic and then shoot that right to the microcontroller, you really expand the reach of who can use that, because a cart full of tablets at a school, elementary school, middle school, that sort of approach is, I think, much more effective than, okay, we're going to march down to the library to use the desktop computers in there. That's more of a constrained resource.
Yep. And never mind that, there's USB cables. There's programming in odd spots. Like, I don't think you could have a microcontroller in a pro product installed somewhere up high, because you can't really update the firmware unless you pre-program in a way to do that. And the amount of times, like, I'm standing at my workbench and then I have to run the long USB lead to my project and then type in some more code, upload the code, then go back to the workbench. Like, it's just, if I could do that on my phone, I think that'd be an advantage for me too. Like, not only students, right? Yeah, for sure. Yeah, it's funny. The long USB cable. This is a very familiar thing, and one case where I'm using this is this woman I know who may be familiar to people who are in the sort of CircuitPython and Python communities. Her name's Thea Flowers, and she runs a small synthesizer company called Winterbloom. And one of the modules, so this is for modular synthesizers, which are what they sound like. You have a rack with modules that each can be patched to each other from the front using patch cables to create sort of the bigger synthesizer that you want. And she has a module that runs CircuitPython on it, and it has output jacks for sending control voltage, which is often how you deal with pitch and envelopes and things for adjusting the loudness of a sound, let's say, as well as gate, which tend to be little on-off switches for controlling when a thing happens or a drum beat. So the whole module is programmable in CircuitPython, and you can also plug it in over USB to a computer or a synthesizer sequencer that can send MIDI signals to it, and then sort of bring this all together into your modular synth. And my computer is about 15 feet away from my synthesizer rack, so I have a really long USB cable that's kind of always connected halfway across the room to be able to, play MIDI onto the synth or noodle with the CircuitPython code that's running on the module. That would be a great use case for something wireless. The latency can be an issue for some things, but if it's just to program the firmware and flash it and then have it be doing something else, I'd love to see that become a little more ubiquitous, to be able to flash these things over the air. I'm on board. I'm all for it. Let's do it.
Heck yeah.
So, we were talking a little bit about, so I guess you have MIDI, or you have a synth rack. What are some kinds of projects that you're working on? What are you passionate about? What are you doing these days?
Yeah, I was mentioning before that I work on these ADA boxes, and they're quarterly, so I have this kind of neat rhythm going through the year where I'm doing projects and writing tutorials for Adafruit, and then they can be just kind of anything that's interesting to me or to Adafruit or a new product. for a little while, but then I start to lock into doing projects related to the upcoming new thing that's going to be in that AdaBox. And so that becomes kind of my obsession for a while, is things related to that. So great example is the one that just released about 2 weeks ago, which was AdaBox 19, and in it is a mechanical keyboard macropad. So it's a 12-key USB keyboard that looks like a number pad on the side of a big keyboard. It's that sort of a design that has a microcontroller. It's an ATSAM D51 Cortex M4 microcontroller on it, as well as a little OLED screen and a rotary encoder, a little push encoder that you can use to control kind of anything you want. It has mechanical key switches, which are where the obsession part comes in, because I've been really into mechanical keyboards for a little while now. Building my own designs of small little macro pads, refurbishing really old dinosaur keyboards from the early 80s that I actually found one in a dumpster that has these kind of cool, rare blue Alps switches in it. So I've been monkeying around with that thing to try to get it to work over USB. And so it was really cool that I got to have this collision of this interest in this sort of fetishy mechanical key switch clicky keyboard thing and this Adafruit product, because unlike the keyboards that I've been using, this one is fully programmable and in a really nice environment, which is in CircuitPython. And you can program it as well in Arduino if you like, and MicroPython, but it's particularly straightforward to do USB things in CircuitPython. It has really nice drivers and libraries for that sort of thing. And so this has underlit NeoPixels, so you can have each key light up to any color you want, or have them do patterns and animations, or just glow a little bit. The screen, you can have it show what your keys mean. And macropads, a lot of people will use those for macros. So you'll say, I just want one key that does copy. So when you press that, really it sends Control-C or Command-C to the computer, but you're not typing two keys, you're typing one, and then another one that does paste. Or you could get a little clever in your coding and say, I want one key that does copy the first time I hit it, and it does paste the second time I hit it, and it always travels between those two states. Sure, why not? That's there's kind of no limit once you get this sort of thing into a nice coding environment. So that's been a lot of fun. Part of it is the research. I really like diving into a community that has passion and sort of extreme levels of dedication. And so getting involved with the R Mechanical Keyboards subreddit and Geek Hack and Desk Authority and a few other some YouTube channels I've been following over the last year is a really fun deep dive into just bonkers enthusiast world of mechanical keyboards. And people take it way, way, way beyond things that I want to do, but I love seeing that level of interest. There are people who take apart every individual switch and they lube the stem, or they change out the spring, or they put a little film of plastic to adjust the way it sounds when you click it, and they fill the keyboard with foam so that it has a certain thud to it. So there's a whole just wild level of passion around the keyboard community. So that's a lot of fun, and I feel like with each of these AdaBoxes, I've had an excuse to take a deep dive into some other world. Maybe not as many of them are as fully realized as that one, but we've done a lot of projects around synthesizers and MIDI, and I really love that stuff, like I was talking about before. And there's a lot of overlap too. So these mechanical keyboards, they can send USB MIDI, and I also made a little adapter so this one can send sort of classic MIDI, which means any sort of synth from around 1983 forward you could talk to with this thing that was made in the year 2021 and runs CircuitPython. So it's a fun bringing together of worlds. I'm also, I think one of the things that I've always been excited about in projects that I've built, particularly some of my earliest Maker Faire projects and Make Magazine articles I wrote, is old and new tech coming together. So I made a project with a friend that was a small standard gauge, was it standard gauge? I think it was standard gauge model train set that just had one straight piece of track that went about 10 feet. And I built a solenoid that would tap out Morse code on a receiver at one end and receive. So you could send telegram messages by rail, which is kind of like what predates the telegraph system, was just sending messages back and forth on a piece of paper on a train. And so, I was using Arduino Unos at that time, and sort of the most modern microcontrollers of that time, and this really sort of ancient idea of then physically driving a payload of some Morse code data down to the other station where it would type it back onto the receiving computer, and so you could have a conversation with someone in a really inconvenient and elaborate way who was actually standing about 10 feet away from you.
That's the most nerdy and awesome thing I've ever heard.
Thank you. I appreciate that.
I find that's actually, model railroad stuff is kind of interesting to me, but the price, like the barrier to entry, is pretty ridiculous. Someone needs to make sort of like an open locomotive that you can just buy some parts and, you know. I don't know if I'm the right person, but someone should do that.
Right. It sounds like the kind of thing that someone could start a whole little Thingiverse model sharing subculture around some sort of open railroading.
That would be fantastic, because I'm just looking up here in Canada, things don't survive as well throughout the ages. So like just looking at like just a starter kit would be something like from maybe the early 90s or the late 80s, and you're looking at like $500-600 for like a really small kit. Yeah,
I've never gotten into. Again, like back at that point when I was doing that project, I was like, this is really cool. What's the sort of dip my toes in it, a little version that I can do that won't cost me too much? And I bought, some. I think that the reason it was the gauge it was is I found that track at an estate sale, and then I ended up buying a train that would fit the gauge, and almost all of the rest of it was just cobbled together parts. I don't even think I had a proper train transformer for it. I think I was just using like a motor controller on a 12-volt transformer or something like that. I don't quite recall.
Is there a sort of dip your feet in price range for synthesizers? Like, is there, we're electronics enthusiasts. Yeah. Is there something relatively cheap we can get into?
No, stay away from it at all costs. No, that's not true, but it is such a dangerous hobby. So here's the interesting thing. The modular synthesizer thing is really appealing if you're into gadgets and electronics and understanding how things work and breaking things down into their elemental level. Real basic version of this is you have a thing that just oscillates. So it's typically called a voltage-controlled oscillator. So maybe it produces triangle waves. Maybe it has a couple modes. It does triangle waves and saw waves, which are a little richer harmonically. And then you need a way to change the pitch. So one way would be with a potentiometer, and you just grab it and but what you want to do is have that be controlled by something else. So this is what the voltage-controlled part of voltage-controlled oscillator is. So you have a little jack, and you plug into that something that's sending a control voltage, which tends to be 1 octave per volt. So these systems often can send 6-8 volts. So you can do 6-8 volt octave range. So you have just this one piece, and typically that's $100, $200 thing. And on its own, it's just going to make a tone endlessly. So now you want to plug another couple of modules next to it that can do things like gate it on and off, and give a shape to that, an envelope, so that maybe it starts softly and ends abruptly, or vice versa. So it's more like a string or more like a percussive thing like a piano, which has a really sharp attack and then a long delay and resolve at the end. So now you've got 3 modules and you're about $400 in. And maybe that's it. Maybe you're just going to, I think that's how I started with modules like that. Then you need a case and you need a power supply. Synth DIY means that you can do a bunch of this stuff quite a bit cheaper, and you can just screw the thing into a cigar box. I've done that. So you can definitely get into it on the cheaper end by doing DIY, and that can be real DIY, or it can be I'm going to buy kits that have been designed and bagged and all the parts are there, or you can do a hybrid where you buy just a PCB and a panel and then you fill out a cart on DigiKey or Mouser and get the parts in and put it together. So there's that starts to bring the cost down actually quite a bit. A really interesting thing though is this all started for me in recent years because of the free and open source app called VCV Rack, which is essentially a simulation of modular synthesis on your computer that in a lot of cases uses real licensed modules that exist in the real world. And so you can try out stuff from this company Mutable Instruments. Many of their modules are available because that particular line of modules are digital. So there's actually software that kind of just works. It's an effort. I shouldn't say it just works, but you're not modeling analog things as much as you are with some other modules. So it's actually a pretty accurate representation of what it would be. And this VCV Rack allows you to really drag little patch cables between things to hook them up the way you want, really turn the knobs, and off you go. And there's lots of great tutorials on there. So I would say that the best way to get started is totally free, which would be VCV Rack. Then you'll immediately go, well, this is neat, but really I want to hold patch cables in my hands and I want to turn knobs because that's what makes me a mad scientist, and that's the super fun part, I think. And so then you're off and running, and maybe it's off into the DIY synth world, maybe it's into buying and trading modules. I lately have been selling or trading modules I have for other ones, there's also a rich community for that, which after your initial investment helps you stave off some of the buying of parts. But it's addictive and fun. And this particular format is called Euro Rack, and it's smaller than sort of the Moog synthesizers that were 5-unit high, 5U of the 60s and 70s and 80s. This is a format that came out in the late 90s, and it's a little bit smaller, so you can get more into a smaller space and reduces the cost a bit.
Why is everything fun so expensive?
Yeah, that's why I say don't do it. And you know what's really funny? The start of this is, for some reason I thought, hey, for Christmas I want to ask for this little handheld synthesizer groove box thing that's called a pocket operator, and it looks like a Game & Watch, like a predecessor to a Game Boy. So it has a little LCD screen and some clicky buttons and a couple knobs on it. From a company called Teenage Engineering, and they cost $50 to maybe $100 for the fancier modules. And it's just a little handheld thing that you can make bleepy sounds on. You can make little patterns and songs and play them back. And it's got, I think there's an STM32 chip on there doing everything, and it has a really great DAC, digital audio converter for the sound, a little headphone out. It has an onboard speaker too. So that was it. It was just, oh yeah, I want this little $60 thing I get for Christmas. And then that turns into hundreds and hundreds and hundreds of dollars worth of real, quote unquote, synthesizers that you get addicted to.
Have you produced anything with that, or is it just purely for the interest? So
I really enjoy decompressing by playing around with these and writing little grooves and jams. And then I started to, a few years ago, write little songs that go behind my videos. So since I produce a lot of little videos for Adafruit that go on Instagram, or little segments of my show. So when I do my John Park's workshop show on Thursdays, there's a segment in there called the CircuitPython Parsec, which is kind of a joke name because we do realize that a parsec isn't a unit of time, but what the heck. So we decided to go with Han Solo's mistake there and call the thing a parsec. That's actually, originally I had a show that was, or a sub-segment that was the Make Code Minute. And now I did that for a couple years, and now I'm doing a similar show on CircuitPython. So anyway, CircuitPython Parsec, I needed to, or wanted to write a little theme song for that. So that's where I actually get to use my synths and recording gear and stuff like that to make fun little jams, little grooves that go on in the background. So I don't consider myself a songwriter, but I get to write these little jams and grooves that go behind some of the video intros.
I didn't realize that the CircuitPython Parsec was actually your own original music behind it. That's pretty. That's really good.
Yeah. Oh, thank you. Yeah, we have a tremendous musician, songwriter, composer goes by Bartle Beats, who has done there's a full Adafruit album by Bartle Beats, and he writes a lot of our more fully realized songs that are behind some of the product announcements or the main AdaBox theme music. He works, I think, mostly in maybe in Ableton or Pro Tools, so on the computer. I don't think he uses hardware as much, but he's fantastic. So he does the real stuff, the really great stuff. And there are actually a number of musicians at Adafruit, Colin Cunningham, Pedro Ruiz. They write great stuff. My stuff is little kind of fun ditties, but I don't put myself in the same level as those guys for experience and accomplishment level.
Well, it sounded professional to my ears, so take that take that as it may.
Thank you.
We're actually in the back half of the podcast now, and I usually ask every single one of my guests the same question, and it's kind of an open one to get everyone's different answers. Can I hit you with that one?
Lay it on me.
Okay, so it goes. You get a government grant, think unlimited funds, to start the business of your dreams. It doesn't have to be profitable, but it does have to provide a service or a product. What kind of business do you start?
Ooh. I tell you, I would love to do something that is a educational makerspace type of thing. So I think if did you say we got a huge grant for this?
Oh yeah.
And it doesn't have to be profitable?
Doesn't have to be profitable.
Great. That's exactly the answer I would give then, because I would struggle with the trying to be profitable part of doing the sort of tech shop, hackerspace, makerspace, but I love the idea of doing a communal space that has tools that don't really make sense for people to have, their own 5-axis mill, but the real resources for training and safety and maintenance and materials to then run classes, have people build the projects they want to build, have their own spaces. So it's really just this is not a unique idea. It's just I would love one that can't fail because these are hard to do. And I've been involved with some maker spaces. I love the idea. They're hard to pull off, but I would have so much fun being able to be involved with or run something like that where you can do classes based on really niche ideas. I would love to, like I say, as I've been getting into things like modular synthesis, I'd love to teach classes on it because I know it would teach me more. So to have a place to do that, and then all the materials to say, all right, if we want to build a thing from scratch, we've got the UV printers to print on metal and do faceplates that are super professional looking, and so all the toys. That's what I'd want to do. When I was in my last couple of years at Disney, I worked for Disney Research, which was embedded inside of the Imagineering R&D building, and so I had access to these incredible shops. There was a machine shop, wood shop, stuff for doing materials and plastics and injection molding and things like that. That shop was so amazing. I would love to bring that type of a unbelievable workshop out into a community space.
Yeah, absolutely. And about the profitability concerns, I feel like a lot of the things you gain by increasing your skill sets are not tangible. So makerspaces struggle because they don't bring tangible results in terms of like employability and revenue generating.
Right.
Like building your own, like learning how to use a new tool does worlds for a person's self-esteem, whether or not we acknowledge it. But there's no dollar amount to that. Like, how do you measure how much better off a person is before and after? And that's why to me it's important to just ignore the profitability. There's some things that we don't need to factor profit in. And when you're, especially as a teacher, and you've done teaching too, you should know that just the satisfaction that your student gets from actually understanding a concept that was completely foreign to them hours ago is like priceless.
It's tremendous. Yeah. And I feel like there's a sort of holistic whole body learning thing where it's really beneficial for people who are doing things like computer coding to learn to do physical skills, and vice versa. People who do a lot of hands-on stuff to do some sort of puzzle-solving, logic-y kinds of things on computers. So I think that this is, I suspect, one of the reasons that a lot of the makerspaces that are still running are corporate ones. There's a really nice makerspace inside of Microsoft, and there's a really nice one inside of Boeing. Like, a lot of companies who can afford to do this are realizing that allowing people to go take a welding class during their lunch breaks is good for their overall esteem and confidence in what they're doing, and maybe unlocks problem-solving skills in an area in a way that you just couldn't predict. So I do believe that there's a lot to be said for just what you said, which is it's hard to say. There's the tangible, okay, you can go out and get a job now based on learning to program a microcontroller, but there's a larger learning, I think, that goes on.
Yeah, absolutely. And I mean, if I can, I mean, I hope I don't come off as offensive, but if I look at your background, looks like you took school in the arts, and this is a skill that a lot of people look over, like especially people who consider STEM, science, technology, what engineering and mathematics, is that what it is, STEM, and they forget that at some point you're going to have to present your findings in that field. Right. And this is why arts is so important. If you don't know how to communicate what you're doing, first of all, who's going to care? And second of all, who's going to even understand what you're about? And I think you're kind of the perfect example here, because you're not doing what you went to school to do, but you're still doing what you went to school to do. If you're using the skills from both ends.
Mm-hmm. Yeah, that's a good point. In fact, I'm sure there are certain professors of mine who, if I asked them, would say, well, yeah, this is not surprising at all that this is the type of thing that someone who came through this program ends up doing, even though the obvious thing is, well, I guess you're going to go out and audition for acting jobs. That's there's a lot more that you gain from, you said one of my favorite phrases before, which is creative collaboration, and that's entirely what all my careers have been about, creative collaboration in one way or another, and that's entirely what studying theater in college was about. We're putting on a play, so that means we have everything from it could be one that's written by a student, it could be one that you're staging that's already been written, but now you're making decisions about what's the production going to look like, who's going to be cast in it, how are you going to rehearse for it, what are the technical things happening in the show, what's it going to look like, what's the lighting scheme for it, backdrops. Now you're building all that stuff. Now you're programming light boards to do the programming and the sound, and you're building props, and on and on and on. So as well as the management aspect of it. People who are stage managers in theater are just the skill set that they gain is tremendous, for useful things out in life in general. So I would say that in a lot of ways, theater is the original STEM, because I don't know, at least where I went to school, University of Virginia, in the theater program, you didn't get to just take acting classes if that was your focus. You were going to take set design classes, costuming, so you are forced to kind of deal with all aspects of STEM. You're doing math to figure out things for building stairs on a stage and so on. So there's a lot to be said for it, and it was just purely by me going, this looks interesting, that I ended up doing it. I did not envision any of those longer term benefits at the time.
And I think another point is that I think we've all had a teacher, whether it be in elementary or high school or in higher learning, that was absolutely brilliant. Like, these people were absolutely like a shining star of intelligence, but they were terrible professors. They were terrible teachers because they weren't good at telling the story. They weren't good at organizing their thoughts in a way that you can bring someone along for the journey of learning, right? Like, you can't, like programming and I never got along. And if you just stand in front of me and you say, yeah, you're just going to have to use, a function for that, and you don't know how to explain what is a function, I'm not going to get it. It's just not going to work.
Yeah, it's interesting. I had a real breakthrough with programming, scripting, simple kinds of programming, when I was already working as a computer animation professional, because the software we were using had a C-like scripting language in it that allowed you to really extend it, because otherwise it looks like GUI-based software. You click buttons, you do things, but it had this whole layer where you could access everything the program could do and then some if you learned this C-like language. And suddenly programming mattered because it was immediate and visible to me. It was visual. So the fact that I could see results in a fully realized graphics program was eye-opening for me. And everyone will be different. There's probably people who would learn programming better if they were doing it with audio software or who knows what. But that was, I think that's a challenge, is figuring out. There's a lot of diverse ways that things will click for people as students when they're learning things, and it's hard to get to them all.
Yeah, absolutely.
By the way, I've realized to expand a little bit, I hope this isn't cheating, but on the question you had about you got the magic grant money and you can build your thing, part two of this is I would love not only for the thing to be a makerspace, educational space with all the gear and tools, but also a really almost like a performance space. I would love to have the ability for people to present things in wild ways, do their own mini Burning Man show right there, or my hobby is I train as a circus aerialist. I would love to have the rigging and everything available to do that type of stuff, circus things, or flying gear around on a stage. So I'm just mashing things together here, but that since those are passions of mine, that's part two, is I want the space to actually not just be a makerspace, but a place that you would hold events and have people come in. So if anyone has the money for this, please hit me up.
I'm sorry, but you don't just get to drop circus aerialist into a conversation and just move on. We can't just leave that there. So, so what? You have a hobby, like basically as like training?
I train at a circus school. Yeah, there's a circus school called Circus School LA here in East Hollywood, and I've been training there in aerial straps for about 4 or 5 years now. Loads and loads of fun. I wish I'd started it 20 years earlier than I did. My body would be happier about it too if I'd started a long time ago. But it's a lot of fun, and I mostly train. We get a chance to do performances or recitals. Not so much in the last year and a half, but and there are circus festivals, and I know people who go out and perform in some of the clubs in LA that can support that sort of thing. And our coaches are all working professionals in various circuses or sort of traveling groups. So it's a ton of fun.
That's extremely impressive. You are truly the Renaissance man, aren't you?
Well, well, thank you. I just love being enthusiastic about things, and am really fortunate to get to pursue a lot of those things I'm interested in.
Yeah, I guess you also have an environment where you have all this available to you. Because I think if I want to go to circus school, the closest one would be either Montreal, which is 2 hours away, or Toronto, which is 4.5.
Okay, yeah, Montreal is the epicenter, though. That's like, you couldn't ask for a better place to go do circus stuff than Montreal.
Yeah, this is very true. Montreal is it's a special place for sure.
Yeah.
It's like micro LA. I think that's what it is. It's like micro LA.
With way more sort of history and European charm.
Yeah, definitely. And it's like basically Canada's melting pot example, because I don't think you can look around the street and see 3 of the same ethnic group person in a row. I don't think it's possible.
Wonderful. That's wonderful.
Yeah, it's an amazing place. Amazing food. Very, very different place, I will say.
Yeah.
Well, all right. We're at the very end here. Can you let the listeners know where they can find you, where they should go visit, any websites you want to promote?
Sure, yeah. If you go to, my website is jpixel.net, jpixl.net. I don't really blog there much, but I have links there to my YouTube playlist on the Adafruit channel, I think to my own YouTube, which I am sporadic about. And then at John Edgar Park is where you'll find me on most social media. So I tend to be on Instagram and on Twitter the most, showing stuff, even circus stuff occasionally. But that's where you can go to see projects I'm working on, or fun old tools that I find at estate sales and things like that. So those are the best places to find me. And then just in general, on Adafruit, you'll see I have a couple of weekly live streams on Tuesdays and Thursdays, and those are on all of the different channels that Adafruit broadcasts, particularly on YouTube.
And probably Adafruit, you have some NDAs about upcoming stuff, but do you have any teasers for your personal stuff that you could you could just drop a teaser for?
Let's see. So we will say that the next AdaBox is in October and is therefore going to be a Halloween one. And in the past, we've done some pretty cool LCD panel eyes that you can use as a mask or inside of a creepy decoration. So look for October Adafruit to do something Halloween-y and a really cool microcontroller-based product. And then in my own personal work, I'm still working on a couple of these different little macropad designs. And I just, speaking of estate sales, picked up a Model 500D classic Bell phone, black rotary phone. And I've done some projects before integrating these rotary phones with microcontrollers, and I'm really tempted to do something again with this one. So look for something coming with a rotary phone. That's pretty likely.
If I can pitch you an idea, a friend of mine, another maker, he set up an old school phone like that for when you pick it up, it tells you a joke. So I don't know.
I love that.
Yeah, I don't know if you're interested about that, but it's pretty hilarious.
I dig it. Very cool. So we'll see what comes from that.
Awesome. Well, thanks so much for taking time out of your busy schedule to come hang with me. Dan,
thank you so much for having me.
110-degree weather in your workshop.
Yes. We'll survive this somehow, I hope.
Yeah, for us, it's supposed to break for tomorrow, so I'm glad because my other workspace that I have to be in tomorrow does not have air conditioning.
Oh boy.
Yeah.
Good luck with that. I always feel bad for the tools and equipment in here that are actually putting up with that heat when I'm not in here with the AC on. Mostly things seem to survive, but it's touch and go.
Well, maybe you can get an extra contract as Adafruit's severe weather tester.
That's probably half of what I'm doing here.
All right. Well, thanks again for joining me. And for the listeners, make sure you go check out John's stuff. All the links are in the description or the show notes, depending on where you're listening to this. Thanks for listening. We'll see you guys in the next one.